Alright, Algebra 2, Chapter 8, Review, Part 3. Alright, now we're going to go ahead and we're going to condense a log expression. So let's use the following example. Let's say we have log 9 minus log z. Well, my subtraction tells me that I'm going to have to do some dividing. They are both log base 10, so we can simply say log 9 divided by z. You have condensed the expression. Alright, let's go ahead and expand. We're going to make it larger. So let's say we have natural log 3x over 7. Okay, this is division here, so that means when we expand, we're going to have to do some subtracting. So let's just go ahead and take care of that part first. Let's say natural log 3x minus a natural log 7. Okay, in class I told you guys go back to the beginning of your expression, see if there's anything else that can be expanded. Well, here you see we have a 3 times x, so we can expand this also using addition. So we'll say natural log 3 plus natural log x minus natural log 7. Go back to the beginning. I don't have any powers I need to worry about. We are done expanding. Alright, next we're going to use the change of base formula. I taught you guys this at the very beginning of the chapter. So let's say we have log base 7 of 12, and we want to figure out approximately what that is equal to. All you have to do is log 12 divided by log 7, punch that into your calculators, and you will find that you get approximately 1.277. Alright, the next example we're going to go over is example 4. Alright, we're going to do example 4 on page 476 of your text. Alright, it says you buy a car for $24,000. New car. So you buy a new car for $24,000. It decreases at a rate of 16% each year. How much is the car valued after 2 years? Okay, so one that you buy a car for $24,000, it decreases at 60% each year. How much is the car after 2 years? Or how much is the car worth after 2 years? Alright, so we're going to use the following model. Y is equal to A times 1 minus R raised to the t. Remember, A is your initial amount, your beginning value, starting number. R is your rate, usually a percent. T is your time. Well, we know when we bought the car we paid $24,000. We know it's decreasing at a rate of 16%. We're going to turn that into a decimal. And we want to know what it's worth after 2 years, so my exponent t becomes 2. So we would do 24,000. 1 minus 0.16 is 0.84. And raise that to the square, to the 2. Alright, then we can just punch into our calculators. 24,000 times 0.84 squared. Alright, so after 2 years, my car will be worth approximately $16,934.40. Okay, again, that is example 4 on page 476, and this is an exponential decay model. Alright, now let's go ahead and work on an exponential growth. The formula is going to be A is equal to our principal times 1 plus the rate over n raised to the n times t. Okay? So your principal is your initial amount of money. Okay, R is rate, T is time, and what we have to remember is that n is usually referring to how often you are receiving the interest. So, like, is it compounded yearly, quarterly, monthly, so on. Alright, the example that I'm going to work on with you right now is going to be compounded continuously. Now, what continuously means is it's going to be compounded every second. So what you really have to think about is how many seconds are in a year. Alright, so I know that there are 525,600 seconds in a year. So this is what we are going to use for n in our model when we start talking about how much interest we have gained and our total amount of money after a certain amount of years. Alright, so let's say that Alright, so let's say we go to the bank with $1,000. Our principal is going to be $1,000. Alright, we're going to be earning interest continuously, so that means every second. I want to know how much I'm going to have after 4 years if I have an interest rate of 5%. Actually, let's go ahead and make that 7%. Alright, so let's go ahead and fill in our equation. A is going to be equal to my 1,000 times 1 plus my rate of 0.07 over the total number of seconds in a year, and I believe we said that was 525,600. We got to raise that to our NT. Well, our N is 525,600. And I want to know how much I'm going to have in the bank after 4 years, so T would be 4. Alright, so what we'll do is we'll go ahead and punch this into the calculator. Be careful of using your parentheses. So if we do 1,000 times 1 plus, I'm going to use another set of parentheses to separate my fraction, 0.07 divided by 525,600, and parentheses, raised to 525,600, and I want to know after 4 years. Alright, and once I punch it into the calculator, I find that at the end of 4 years, earning interest continuously every second, I should have in the bank approximately $1,323.13. Okay, and we'll review this again in class so you have a full understanding of what they mean by compounded continuously. Alright, this concludes your chapter review. We will go over the exact same problems in class, so if you view it ahead of time, make sure you have questions prepared so that I may answer them for you.